for the remainder of the day is to get your brain thinking statistically. So you can just sit back and let this wash over you for the next 20 minutes or so. These are just some little things I've collected over the years, kind of things that I've collected. Some of them are fairly old, 5, 6, 7 years. Some are recent, as in this past year. There's certain skills that statistics requires that traditional math classes don't demand of you. For example, fact checking. In Math 111, you learned something called the rational roots theorem, I would imagine. You know, any rational root of a polynomial, that was like, yes. You know, any rational root is a form, blah, blah, blah. Nobody ever asked, like, why? You can prove those things, just like I did on the enrichment page, but nobody bothers to do it. Nobody asks you to fact check. So here's something that I was told by Kate Couric back in 2006. It's a little bit old, but I love this example. We'll get more current examples, too. 733 children were food poisoned in American schools in 2006. And they had all this video footage of rats running out of dumpsters behind school buildings. And, you know, food sitting on the floor, food getting dropped and picked back up. All this stock terror footage of how awful it is to eat in a school cafeteria. And she was making a big deal about 733. Well, what can we do to clean up our school cafeterias? And the first thing I thought of was, that doesn't sound like all that many kids. I mean, it's terrible. Kids getting sick is terrible. I'm not trying to be a bastard up here, but I can't do the school. Stop vomiting with your friend. So what I did was I wanted to temper it. I wanted to fact check that number and compare it to some other numbers that I fact checked. So I went to the CDC website, Center for Disease Control. 76 million food poisonings happen per year. So I've got 733 and I've got 76 million, a few orders of magnitude different. But then I thought to myself, okay, that by and of itself doesn't tell me anything. I've got to compare not just the food poisonings, but also what? Right, the number of people available. It's almost like a percentage like your grade. You've got the points you've earned and the points you could have had. So here are the points we've earned, so to speak, 733 and 76 million. So I'm going to start with the 76 million. I assume 300 million Americans. This is called a back-of-the-envelope calculation-ish. It's not 300 million. It's like 310 million or something like that, but whatever. It's also not 76 million. That's an estimate, too. So let's estimate. 76 million over 300 million Americans, but remember, they eat more than once a year. So I'm going to assume they eat 3 times a year, 3 times a day. 3 times a day, each day. 3 times a year. 3 times a year, 365 times. So this ends up being, if you will, the percentage of food poisoning, or the chance of food poisoning. Any one of you. You've got a 0.02% chance of food poisoning. All that means is, of this many meals eaten, there were that many food poisonings. So, if you will, 2 per 10,000 or 1 per 5,000 meals resulted in a food poisoning. That's what that number means. 1 meal per 5,000 resulted in a food poisoning. Cool? What should we do next?
For children?
Yes. The same exact thing with the school kids. So I did some research. About 75.8 million, exactly right, 75.8 million school children. That's a sizable chunk of the overall population. That's roughly a quarter of the population, right? So, as soon as you weight it, even when you make it even worse by multiplying it by 180, which, assuming they go to school 180 days of the year, which is a far cry from the truth anyway, that's the chance of a food poisoning in a school, which is 4,000 times less likely. So, in other words, CNN's trying to make me think that kids are getting sick at record rates in schools, when all you've got to do is compare it to the overall population. And I say, hell, let's go down and eat at Summit. Or Mountain Dew or Ben, don't want to be specific. But that's the point. That's the point, is that number by itself means absolutely nothing. When you compare it to something else with some fact checking, all of a sudden it's like, oh my goodness, look at that. Look at that. Please, tell me your name again, sir.
Robert.
Robert, thank you. Go.
Do you think that's intentionally deceitful? Or just
Hell yeah, it is. Yes. Go. I cut you off, my friend. Go ahead.
Or they're just, not very educated and do it improperly.
I think bad news sells media.
Yeah.
Bad news sells media. 76 million people getting sick every year from food poisoning. That hasn't changed in years. I'm sure that was news at some point. Mm-hmm. The thing is, I bet you the 733 was up from 500 the year before, or something like that. And then they can make the claim, since it went from 500 to 700, that we're up 28% from the year before. And you're like, oh my God, 28%. No, not really. The number of food poisonings is up 28%, but if you look at it as a fraction of the overall total, it's up an incremental percent. So what they've chosen to ignore that, they've selectively ignored this part of the calculation. So a little bit of it is ignorance, and a little bit of it is just, I want to sell this number. Bruce will tell you, he knows. So I think a little bit of both, but I know bad news sells. That's for sure. That's for sure the truth. Here's another one for you. This one came across my Facebook page about 6 months ago. So it has to be true, of course. Now take a look, take a look. I'm not pushing a political agenda on any of you, by the way, just so you know. I'm not. I loved this one. And it was awesome watching my conservative liberal friends be divided by this image. And they kept asking me, what do you think, Roel? What do you think I told them? What do you think I told them when they asked me what I thought?
Well, it's manipulative.
Robert, go ahead. I'm sorry.
It's manipulative.
How? Tell me why.
Well, notice that they like minimize the size of the type, and then it
Oh, good.
grows.
Oh, just the presentation itself. Good for you. Good. I wasn't even thinking of that. Good for you. So yeah, it gets more bold. It gets bigger font.
And they change the color.
And the pictures.
Big.
Yeah, the good. The color gets red. 600 times more likely to die using Obamacare. Please, Jenny.
There's way more people using medical care than there is having guns.
Once again, we have selectively ignored the denominator. Assuming these numbers are even meaningful, which I haven't fact-checked any of them because I can't find them because I'm not sure they're right, but assuming they are, we haven't weighted them at all for a percentage. Yes, maybe this is true. Define medical malpractice. I don't even know how to define that. But even if that's true, let's divide that by the number of cases in, and let's compare that to the number of AK-47, whatever the hell gun that is. I don't know. I'm sorry for anybody that understands guns.
It's an M4.
Thank you. Thanks. Sorry, Patty. I'm sorry. I don't know. That gun. Let's divide that by the correct denominator and see if the percentages indicate the same raw numbers. Kelly, go ahead. You sure? Okay. Here's the thing. 323 by these. Is it that particular gun or is it automatic weapons? I don't know. 496 by these. Is it a hammer? Or is it that particular hammer? Is it a tool, a 2x4? 650 by a kitchen knife or a knife? You know, there's all these questions that this picture doesn't answer. And I'm assuming that all of these are assaults or something like that. And then you've got drunk driving, which can be considered assault, I would imagine. And then you've got medical malpractice. What's the relationship? The relationship is somebody is trying to get you to not believe in Obamacare. So they're putting a bunch of meaningless, in my opinion. That's why I didn't answer. My friends want to know, what do you think? I'm like, I think this is crap. I got no political affiliation with it. I think it's garbage. It doesn't tell me anything. It's hidden. It's hidden data that's hidden behind this poor picture of Barack Obama looking sad. Honestly, that's what I see. So be aware. How many times do you see things like this?
Oh, there's
all the time. CJ. JC. Damn it. JC, there we go. Yes, all the time. It comes across your Facebook page. It comes across your email. All the time. All right, let's keep going. Here's some numbers that I think that are actually fairly impressive. These are all fact-checked and sourced. I've got them at the bottom as they one by one pop in. I'll have the sources at the bottom. Some of these are just amazing to think about, the scale of the numbers. The numbers themselves, I think, stand on their own. 1 billion people watched the 2006 World Cup final. Any of you guys watch that one in 06 where Zidane headbutted the Italian guy whose name I forget? Who's the Italian guy he headbutted? I can't remember the guy's name now. Yeah. 1 billion people watched Zidane headbutt that dude. It's amazing. Not as many watched the 2010 final, but that was 1 in 6 or 1 in 6.5 people on Earth watching the same sporting event. I saw a video of a tribe in Africa sitting around a TV hooked to a car battery watching it. The most powerfully amazing vision of a sporting event I've ever seen in my life. I mean, Super Bowl, whatever, honestly, when 1 billion people watch a soccer game, it's crazy. I like this one an awful lot. This is, again, one of those things I call a correlation more than a causation. Do you remember back in 07 how much gas cost? It was like over $4 a gallon, remember that? 4.20, 4.10, 4.20 a gallon. Remember what happened in 08? It went down. Between 2007 and 2008, we as Americans drove 30 billion fewer miles in that month, in the first few months of 2008 versus 2007. Now, why did we drive fewer miles? I would imagine we were coming up with pretty selectively clever ways of getting around paying $4.20 a gallon for gas. And I'd like to thank the American people for driving the cost of gas down. I'm going to call it supply and demand. I'm in the business department right now. I'm going to plead my ignorance for business principles, but I believe supply and demand says you remove demand, supply goes up, price has to go down. I think that's the way it goes anyway. I'm going to give American people credit. I can't prove it, but that happened. Isn't that crazy? 30 billion fewer miles. Let that number, we'll come back to that number on Thursday, I promise. Let that number kind of roll around in your head. Staggering. We'll come back to the debt as well. 550 million people using Facebook. That was as of 2011, and God only knows what it is now. It's the third biggest country on earth, behind China and India. Isn't that crazy? And I love the next, in the time it took you to read that last sentence, they uploaded 5,000 photos. And this is before Instagram was popular. God only knows what it is now. So, and here's your sources. I think those numbers are just kind of staggering by and of themselves. Like, these are numbers that stand alone on their own. So anyway, fact-checking I think is important. Fact-checking is, I think, important. Here's a little bit of fact-checking combined with what Robert brought up. You brought up a point earlier. I want to come back to that point. This is an article from about a year and a half ago from the Broadside. FYI, I love the Broadside. I do. Broad. Sorry, I'm going to my Delaware room. Broadside. Love it. This was the article when tuition went up 2 times ago. $4 per tuition. This was the graph that accompanied that article. Okay? Which brought me to send an email to the Broadside asking them that to reprint a graph that was less skewed. This graph, unfortunately, is not accurate. Can you see why? This is a misleading graph. Can you see why? It has something to do with what Robert mentioned earlier. It's a more 2-dimensional versus 1-dimensional thing. But you hit it on the head earlier, Robert. Anybody see what the problem with this graph is?
Making it look more than.
Tell me your name.
Michael.
Michael, tell me how. He's making it look more extreme than it is. Michael, go.
Because the graph on the right is like 5-6 times bigger than the one all the way on the left. It's really okay.
What's that dollar amount right there, friends?
Yeah.
Right? That's $32, correct?
$32.
That's $32, which makes perfect sense. If it's $4 more per credit, 8 credits, that's $32 extra you're paying, right? If that's 32, how can that be 528? Shouldn't that be about 100?
Yeah.
There's the problem. Here is what the graph should look like. But what they did, and this happens all the time in mass media, they chopped the graph right here and threw the bottom part away, and then stretched it to fill the same space. And as soon as you did that stretch, and this was completely due. They were not trying to be malicious.
No.
They were trying to save space in the paper and fill the space better. But inadvertently, they created this alarm, like, oh my God, I'm paying so much more. No, you're paying $32 more over the course of that 8 credits.
Mm-hmm.
Now, granted, that's more, but nowhere, as Michael pointed out, nowhere near as much as it appeared to be.
Mm-hmm.
So, you guys kind of buying that?
Yeah.
We'll revisit this one over and over again, because this happens all the time. That student debt, the student loan debt image from before, case in point. Different formulas used versus area and length, 2-dimensional versus 1, but still the same kind of unintentional deception. And that's why, Robert, your question before, did they mean to? They did not, because I talked to the folks that made the graph.
Yeah.
And they felt appalled when they were done. And I wasn't trying to make them feel appalled. But they understood what I brought up.
Right.
This is why it's so important you're sitting in this class learning this stuff. Because otherwise this stuff goes by unnoticed in your subconscious. I've mentioned this a few times today. Certain things happen in line with other things. That's called a correlation. A causation is one thing actually causing another one. So here's an old correlation. Ice cream sales are correlated with crime rates, which means as one goes up, so does the other. And you guys, this will all be posted for you to check out after class. You don't have to take notes or anything like that. You can just kind of let this wash over you. So therefore, let's stop selling ice cream and crime's going to go down. Clearly. Clearly, right? Which would be a statement for somebody who's confusing correlation and causation. So that's one possible conclusion, therefore, is that since they're correlated, one is causing the other. Sometimes correlations do cause things. What do you think about this one? It's warm weather. What's it got to do with anything? Tell me your name.
Dawn.
Dawn, thank you. What's warm weather got to do with it?
People eat more ice cream
Okay.
during warm weather, and people are also outside and looking for things to do because they're bored.
Oh, more people outside, more people bored, more people maybe leaving the doors open to their house. I used to live in Delaware, right near Philadelphia. It's amazing to me. I left my garage door open last night, which it annoys me for 2 reasons. Number one, it's 37 degrees and I'm heating the outside. But number two, everything's still in the garage in the morning.
Yeah.
I lived near Philly for years. You leave your garage door open, you're lucky if you're in your house the next day. I mean, it's incredible to me. I got back outside, I'm like, damn, the door's open, the cat's freezing on the block of the engine, like trying to warm up. But the canoes are still there, and the bikes are still there. I'm like, oh my God, I gotta be in bed. But that's the thing, warm weather, doors open, access to houses, People get somebody said agitated in the other class. People get agitated more in the warm weather, therefore they're, I like all that, and that's an alternate possible conclusion. Yes, both ice cream and crime rates are thirdly correlated with the weather being warm, which probably is causing both. Yes, I like that very much, Dawn. Thank you. Here's one that's not as obvious. Check this one out. You got to remember too, correlations are average correlations. I mentioned this before. On average, the more quizzes you do, the higher your grades are in the class. I mentioned that. That doesn't mean that every single person who does more quizzes gets a higher grade. It means if I average all those grades, they average to a higher grade on average. On average, the number of daughters in a family is highly correlated with divorce rate. So, that's arguable. I like that, Dawn. I've heard that. There are more girls born than boys. I keep seeing studies that contradict that. And I think the problem is, there's a thing called a margin of error on any study. So, boys and girls, we always assume 50-50. It's like flipping a coin, or pulling a red card or a black card over dead. That's not necessarily true. There tend to be slightly more girls than boys. My argument is within a margin of error, it's not, but it is true. There are slightly more girls than boys, which actually helps answer this, at least according to one of my students. Let's come back to that. Anybody have a theory other than the fact there are more girls born? How would that tie into the divorce, just out of curiosity, since there are more girls born?
What's that?
How would that tie into the divorce thing? There are more girls born.
Well, if you're saying parents who have daughters are more likely to divorce, if there's more girls born, there's more families that have daughters in them.
Oh, so you're not only assuming more daughters, but more daughters per family. I was assuming more of a uniform distribution. So even though there are plenty more girls, we still got 50-50 mixes of boys and girls in the family. I see what you're getting at. Okay, so you're applying the divorce rate uniformly. Okay, I like that. Anything else? Max?
Okay, I was a little confused by what she said. Was she saying that because there are more girls born than boys, that there'd be more families that have girls?
That's what she's saying, exactly.
Ultimately, okay.
So ultimately, you apply the divorce rate across families with more girls, assuming that the divorce rate, so in his claim, this was Stephen Levitt's claim. His claim was the divorce rate falls more on the families with girls. So are the girls causing the divorce?
No.
That's the question, I guess. No, so it is.
Well, I would say that,
Jamie?
yeah. Some people would say that, like, boys are less stressful, easier to raise, that kind of
You mean
thing.
mine?
And stress would cause divorce. I don't think that the daughters are the reason, but the stress level that could.
I love what you're saying, and one of my former students agreed with you. I had no answer for this for years. I left it open. Like, what do you guys think? And I kept hearing comparison. One of my students told me this last term. Two terms ago. More girls born. Maybe the stressed part of the population is producing the females. And it's true, as far as I know, it hasn't been rigorously studied in humans, but it has, I learned a new word last term, ungulates. Clove animals, I think is the correct, what an ungulate is, like an elk or a deer or something like that. Apparently ungulates, when they're stressed, produce more females than males. And apparently the reason is because it's a lot of work to insert the testosterone, the added Y, the Y chromosome, if you will. It's more work, so the stress, the energy has to go to keeping the mother alive. So we're not going to creating males, but keeping the mother alive. Therefore, we produce more girls. So it's not that the girls are causing the stress, necessarily. It might be that the stress is causing the girls. How about that? Is it right? Hell if I know. It's a totally convincing argument for me. I don't know if it's right or not. It makes you think though, right, Andrew? It makes you think. It makes you kind of scratch your head and go, okay, I buy that. I mean, rabbit populations actually reabsorb embryos in stress situations, but certain species actually pump out more females. Please, Harrison.
So with feed cattle, sex is determined by the male.
And that's the same
Which
as
is
or as human.
Okay.
Males determine the sex of
So then that throws the whole theory out.
No,
It
but
doesn't,
it's a
though.
man.
It doesn't. Hit her with the biology. Hit her with the biology.
Everything is born, or everything when they start is all the same sex and as it. Isn't it? Am I wrong?
You're asking the wrong
Or
person.
don't they-
Seriously.
Don't all embryos start out?
I'll let you guys loose on this one.
You have to, yeah. Y or an X, and then it fertilizes, and it's either gonna be
But
male or.
it says stressed populations, the male could be stressed as well. You guys are assuming, right, and if the male is stressed, maybe the male does then, you said the sex determined by the male could then choose, if you will, the female path. I'm playing in the playground, I really don't understand that well. But the population is stressed, doesn't mean the females are stressed, it just means the population is stressed, which might produce this, we are seeing more and more arguments that there are more females than males in our population. That could be part of it. Again, could be, it's great, right? James, great. Harrison, I don't know. I'm putting it out there. Cool? But you see, these are the questions it raised. And then you bring up and you have these discussions and you have more original. There's no correct answer as far as I can tell. That's the closest I've gotten to a correct answer. It's just because it's a convincing answer. All right, one more thing I want you to think about. Anytime you do a study, whether it's, are there more girls than boys, does yellow and red actually grab your attention, you have to set up a controlled group, exactly, to test. Or sometimes more than one control group, maybe 2 groups or 3 groups. And randomness, which we'll come back to on Thursday, I'm going to plant the seed with you right now, is one of the most important parts of setting up a study like that. Making sure you select a random selection from whatever population you're studying. So I want to test your guys' randomness a little bit here. I've used Excel to generate 30 random darts and throw 30 random darts at a 1x1 dart board, if you will. Now, granted, it's 1x1, but it's stretched like a rectangle, but you get the point. You can squish it down and make it a square if you want to, but it fit better this way. So I want you guys to spot the fake. In which one of those 2 dart boards did I actually throw 30 random darts? And in which one did I try to make you think I threw 30 random darts? And the answer could be either of them. But my question to you is, which one is more likely to actually be 30 random darts? Which one is, what do you guys think? Harrison, what do you think? The bottom one is most likely to be 30 random darts. Why do you say that, my friend?
Just because if you're throwing darts, you're probably not going to be able to space them out that evenly.
Why not?
Just the randomness. Like it's not
There's 4 pens dropped on the ground. What happened?
They bunched.
You got a bunch of 4 over here and a bunch of 2 over there. Now, granted, they bounced off the wall, but those didn't. So your theory is that we should see bunches. Is that fair? You guys okay? So to reinforce that, you're absolutely correct. The fake was at the top. I created it in this spreadsheet right here. And what I did was I randomly generated numbers over here, and I plotted those darts right here. Look what happens. Every time I generate new ones, what happens, Natalie?
It's all random.
They're all random, and what are some of these darts doing to each other?
They usually have to form little groups.
Clumping, I love that word. Make little groups, little clumps.
Yeah, clumping.
Now, could it be that this could actually happen with 30 random darts? Yes, but which one is more likely?
The bottom.
This one. As a matter of fact, this one started life as this one, and then I took it in paint and I moved things around to make it look like the top. So it definitely is the fake. It definitely is the fake. All right, friends. You ready for another one? Here's the last one for you to think about today.
the one I thought of.
Is this what you thought of? This particular example? This is 200 coins flipped.
Flip heads or tails here.
Good! 200 coins flipped heads or tails. Actually, I used Excel to do it. So one of these is me actually using Excel to flip 200 coins, or if you took a quarter and flipped it 200 times, and the results of heads and tails. One of those is actually real, and one of those is fake. So I want you to think about this. Which one of those is more likely to fake, and which one of those is more likely 200 actual coins? Good, JC. That's good. That's good. She's like, oh. Or maybe the vote is, I can't tell. Maybe they both look good to me. That's possible. It's not quite as obvious as the dark one, is it? It's not quite as obvious as the dark. What do you guys think?
I think the top one's the right one.
Candida says the top one is the right one.
That's the
I
one
really
go.
can't.
We've seen some nods. Jamie's agreeing. Kelly's saying no.
I can't tell.
Kelly can't tell. That's okay too. And I'm not saying either couldn't be random. I'm saying one is more likely to be random. Hattie, what are you going with? Top or bottom? Going with top? We get a bunch of tops? Okay, lots of tops. Okay, you're correct. The top one is more random. Why?
There's more.
Candida, go.
For me, what stood out was there was a lot more H's, a lot more heads than there was, that's what it looked like.
That's okay. And that could be a function, that's an inadvertent bias I create by using the letter H versus T.
Yeah.
It's unfortunate. What I did was I recreated it here in Excel. Now watch when I press F9. What do you notice that happens in this particular one that didn't happen in number 2 and the PowerPoint? Go ahead, Jenny.
Well, you're having like T's together in larger groups and H's together in larger groups rather than one after another back and forth. They're grouping.
How many T's and H's do you get in a row here?
3.
Never more than 3. Never more than 3. You got rows of 5 and 6 and 7 up here, don't you? Watch what happens when I actually simulate this over and over and over and over. What happens? Those runs happen almost every single time, don't they? Somewhere in there. Now, I don't know how, if you're looking at it left to right or up to down. However you're looking at it, those runs exist. As a matter of fact, you can show it mathematically. 96% of the time, you should get at least 6 in a row somewhere if you do it 200 times. Which means I had to go in there and actually create the heads and the tails and the heads and the tails and the heads and the tails in that second one. I had to stop. Okay, I had 3 H's. Now I got to put a T. That's very unrandom. Randomness says you'd actually have this. I mean, look at that right there. 6 heads in a row right there. And if you hit it again, you see 6 somewhere? Yeah, you see 6 somewhere? Yeah, you see 6 somewhere? Yeah, you sure do. 96% of the time, you will see them somewhere. And it's amazing where this pops up. It's amazing where this pops up. How many of you were born in January? January? What day? Patty? 13th?
20th.
20th. Okay, 7 days apart. That close, actually. February birthdays. February birthdays. Sherilyn?
16.
Max?
22nd.
22nd and 20. Well, there we go. We call that a cluster. 22nd February. March. Well, you get the point now, don't you? You get the point. Is that we're going to have these birthdays clustered together. June 28th. Anybody in June?
I'm June.
June 28th.
25th.
16th. 25th. Slight cluster, right? You see what's going on? We got a match. We got a near cluster. Why don't the months just spread out? Why don't we have January 1st, January 8th, January 15th, January 22nd? Because then you wouldn't have randomness, would you? You'd have it ordered. And our lives are very unrandom. We came into this room, it's just like a rectangle.
So then would days like Valentine's Day be outliers?
As far as being born on Valentine's Day?
As far as being conceived on Valentine's Day?
No, as a matter of fact, years ago, October 5th was thought to be the most popular birthday in America. Because it's 9 months after New Year's Eve. For years it was thought to be, but then it was shown it was just a margin of error calculation error. No, and actually, it doesn't seem to have any more births 9 months after Valentine's Day than New Year's Eve, than Christmas, than the winter, than the summer. You think in the winter is cool. But no, it doesn't seem to wash out. It seems to be pretty uniform,
I don't
which is
know.
you guys just
We're
did.
September baby, so something might be said to that.
Well, you're one data point now, aren't you? Careful with anecdotal evidence. Careful with anecdotal evidence. That means your data point, your sample size of 1 doesn't tell you a whole lot. Friends, that's it for today. What are we doing on Thursday?
Quiz.
Bring that quiz. Do you have to do it?
No.
Should you?
Yes.
Yes, all right. We'll see you guys then. I'll get this stuff uploaded as soon as I can.